On today's Emerging Tech Horizons, continuing the conversation with Bill Bonvillian on his book Pioneering Progress, American Science, Technology, and Innovation Policy. We talked today about industrial innovation policy, DoD's role in innovation policy, the importance of innovation policy and industrial policy for things like supplying us with microelectronics. What's the future of the CHIPS Act, and what should the next administration and Congress do to pursue the most optimal innovation policies? Okay, we're talking to Bill Bonvillian from the Massachusetts Institute of Technology, author of a new book, Pioneering Progress, American Science, Technology, and Innovation Policy. On our last podcast episode, we talked a lot about how science and technology, innovation, manufacturing policy shape both our national security and our civilian economy. Bill taught us a little bit about different theories and how they were shaped, some of the origin story of the Valley of Death that we all suffer with and some of us live in. And we talked about the need for manufacturing, both to support a strong economy and national security. Bill, I wanted to keep going on that conversation. In the book, you talk about some ideas to address some of these Valley of Death issues, some of these manufacturing scale-up issues, some of these competition with China issues that you touch on. And rooted in all of the great historic examples that you give throughout this book, things ranging from Operation Warp Speed to the microelectronics effort under CHIPS to scale up during World War II to space race and Cold War. So what do you think is the future here of industrial innovation policy? And I want to start by saying, why is it such a hard thing to talk about industrial policy in this country to begin with?
There's been a brawl that's been ongoing with mainstream economics, which is, historically and not for bad reasons, opposed to what we can call industrial policy, i.e., heavy governmental and significant governmental investment in the industrial side, in the overall industrial part of the U.S. economy. Obviously, there are inefficiencies that can come from that. Government is not necessarily a great picker, as ways goes, of winners and losers. But there are parts of the economy where U.S. has played, the federal government in particular has played a very significant role in whole sectors, right? In agriculture, and a network of policies there really undergird U.S. agricultural system. Transportation, the federal government dominates most of the investment in highways, air train, huge investment in commercial airline support through the infrastructure it provides, as well as technologies. On the energy side, a heavily regulated sector with pretty extensive subsidies. Healthcare, the U.S. is the dominant investor in the healthcare system, particularly for the elderly and the poor, but overall as well. Those are examples of what we could call industrial economic policy. But I'm intrigued and interested with something that's different than that, industrial innovation policy, which focuses on the innovation side, not on kind of these broad economic policy sides. And indeed, as I said before, there has been major opposition from mainstream economics. But let's keep in mind that a Defense Department industrial innovation system, gave us, most of the technology innovation waves in the second part of the 20th century that are obviously still with us today. So we've had a kind of a parallel universe, dueling universe sides to our industrial policy approaches. A heavy industrial policy, and particularly industrial innovation policy on the defense side, less so on the civilian side. with a lot of advances, frankly, that have spilled over into the overall economy from that military industrial side.
So help me think about this. What's the difference then between industrial innovation policy, as you're talking about it, and traditional industrial policy, which has somewhat of a bad reputation?
Well, I think the economists have stopped fighting over things like the federal government's healthcare interventions, right? We
Mhm.
don't see a lot of literature on that very often, right? Uh, there are economic sectors where the federal government plays a very significant role, and I've kind of enumerated what those are, from healthcare to ag to transportation, et cetera, energy. Um, and then, then there's areas where we have much more of a laissez-faire free enterprise system in many ways, thank heavens. Uh, but the industrial innovation policy side, I'm particularly thinking about how that innovation system works, right? And the federal government, for many decades, ever since Vannevar Bush's design through the sciences, the endless frontier policy approach, has played a very heavy role in the basic research investment side, uh, on the civilian economy side. But then it's adopted more of an industrial policy approach to innovation on the defense side. And as I said, earlier, a lot of technological accomplishment for the in the last 100 years have um, come out of that defense led industrial innovation system. But there are new policies that are starting to emerge, right? And the policy drivers have been the pandemic, energy technology investments, and behind in particular the latest efforts have been a technology competition with China. And we've evolved, a series of new approaches, Arun, which I can kind of, briefly enumerate. But what's the governmental role going to be, and how can we keep that governmental role in the most efficient operating manner possible? And we've taken a top-down approach. And I can explain in a minute. We've taken a bottom-up approach. We've undertaken government support for demonstration projects. We've undertaken direct production support, in this case in the CHIPS Act. Uh, we've undertaken supply chain support. And we're looking at, and this is, I think, the hardest of all of them, kind of regional innovation support. Those are essentially the policies we're now pursuing in industrial innovation policy.
Can you
Uh,
talk a little bit about the electric vehicle story in the book?
sure,
That's very
sure,
interesting. And that's an example of what you call bottom up.
sure. Um, you know, Tesla didn't just happen, right? The government provided a network of incentives to scale up electric vehicle production. The incentive, it was bottom up. In other words, the government set up a host of incentives, and it was up to particular companies to take advantage of those incentives, right? It wasn't picking particular winners. It was just creating, a network of incentives out there that companies could pick up on. Tesla did it, right? It's a remarkable story of what Tesla accomplished in terms of being able to build that, very high quality electric vehicles. But it's also underlaced with extensive governmental support. So Tesla was on the verge of bankruptcy in that 2008, 2009 period, very close to bankruptcy. It was rescued from that bankruptcy by a $460 billion loan from the federal government. Uh,
Million.
yeah, it received massive federal and state tax incentives, right? A $6,500 incentives to new car buyers directly flowed to Tesla's capability. The state of California actually had some particularly powerful incentives, and obviously California is a big part of the U.S. auto market, has been historically for a long time. Um, but California, California developed a taxing mechanism because of its air pollution problems, frankly, um, where it taxed car companies for not making electric vehicles, collected that revenue, and gave that revenue to car companies producing electric vehicles. You know, in 2020, the credits that Tesla got for that amounted to $400 million a year. These are very significant subsidies. And let me correct that loan number. It's 460 million that kept it out of bankruptcy. But there have been, a host of other tax and other incentives that went to Tesla that helped gird it up, help sustain it in getting to the point where it could actually produce profitable vehicles at significant scale. Uh, so it's not an historical accident. These industrial innovation policies working from the bottom up, and the bottom up means don't pick particular winners, pick a broad base of incentives and let industry figure out what they want and who's going to do it.
And that contrasts with the top down approach that we saw, Operation Warp Speed, I guess, and I guess that we see in traditional defense procurement.
Yeah, both those points are right. Top down was the approach taken in Warp Speed, and to deal with the pandemic, and we saved, best estimates, probably about 2 million American lives in the course of that pandemic by developing these new vaccines, particularly mRNA vaccines. How did that top-down approach work? Well, the federal government picked winners. It did take a portfolio approach, right? So it wasn't a single winner. Operation Warp Speed, which was a governmental entity created out of a host of agencies and staff from a host of agencies, they selected two leading companies in each of three underlying vaccine platform technologies. And, could they have picked 40 companies? We never would have gotten there, right? The amount of focus, attention, and support required by just those six companies, and five of the six, by the way, got the vaccine approval, was very intense. We never would have been able to manage that process for 40 companies. So picking winners, I think, was necessitated by the nature of the challenge. A key was guaranteed contracts. You can't manufacture without a customer. And, it allowed the companies to take the risk, even before they had final approval of their vaccines, to invest heavily in their production processes. Companies like Moderna and Pfizer, which was allied by BioNTech and Biotech, making mRNA vaccines, which were particularly powerful. The idea here was start the production process, get that underway while the vaccines are still in the later stages of their development processes. And doing that in parallel saved an enormous amount of time and therefore lives. And the government guaranteed contracts were an enabler. There was an important technology certification role the federal government played, right? And we only do this really in healthcare. The Food and Drug Administration, the FDA emergency use approval, assured, in effect, immediate market entry, right? As soon as that approval came through, that approval was respected enough in the society as being, as accurately certifying safe and effective drugs that the public, the great bulk of the public, was prepared to accept it. So when that certification, that emergency use approval came about, that was a very powerful incentive, guaranteeing a market really kind of overnight in effect. And we do that in healthcare. We do that through that respected FDA certification, which remains the most respected in the world. We don't do that in other technology areas, by the way. That it's something we could think about in terms of industrial innovation policy. We can have, some very talented federal labs actually certify product lines for their effectiveness and safety and performance. We don't do that, but that would really help in rapid market creation and reduce risk. We had flexible contracting in Warp Speed. We took advantage of the Defense Production Act and other transactions authorities, in particular, known in the defense world, created in the defense world. We mapped supply chains. Um, we directly supported production scale up. The Army logistics um, team was there to help accumulate the right equipment, get the right production lines in place, providing direct production support. Less so for Pfizer, more so for Moderna and some of the other companies. We integrated federal personnel into the the biotech pharmaceutical companies that were involved here. Uh, they didn't sacrifice anything on the safety front. They weren't there to cut corners on safety regulation. They were there to explain what the standards were that had to be met, and how best to get there. And then we undertook a national distribution system led by the Army under General Gus Perna, a remarkable distribution system. It got it out to the states in remarkable time. mRNA vaccines, which were the most successful, required, you know, hilariously low temperature delivery. All kinds of special packaging had to be developed for this. But the distribution system was put into place, and those vaccines got into the states. The states weren't ready, frankly, in many cases, but they got organized within a month or two, and the vaccine distribution really took hold. So there was a lot of pieces in this Operation Warp Speed, and at the top-down approach, the picking a portfolio of winners turned out to be what was needed there. And the companies weren't selected by accident. They were selected as the most capable firms in those three vaccine platform areas.
Yeah, and it's a couple things. One, ETI, we've done some work looking at that example, Operation Warp Speed, and seeing if any of those lessons learned, all of those factors that you laid out there that made Warp Speed work, can they be applied to the daily life of the defense acquisition system? And turns out the policy playbook is there, right?
Yeah.
Some of those things you wrote, Bill, right? But the ability to shape supply chains, the ability to do other transactions, the ability to enter into undefinitized contracts, the ability to make market commitments, all of those authorities exist in law if agencies can have the wherewithal to make use of them. And there's an agreed upon national mission, that we're all behind, so you can avoid the politics of it all.
Let me just add, Arun, let me add one point here too. One very interesting aspect of Warp Speed was the way in which Warp Speed itself was organized, right? No single agency here had the authority that was needed. It wasn't NIH, it wasn't FDA, it wasn't the Army. We needed a mix of authorities here to get the job done. And we also needed a mix of talent, people that could bring these different skills together. So we typically do interagency coordination in the federal government, by committee, and it is famously inefficient, right? When I was working in the U.S. Senate, taught me that interagency cooperation is a contradiction in terms, and there's a lot to be said for that point. How did we do it so brilliantly in Warp Speed and get vaccines to tackle the pandemic in people's arms within 8 months, an absolute record time of vaccine development, unheard of, frankly. We created a separate organization called Operation Warp Speed, and we took some outside people. Monsef Saloui, who is a pharmaceutical executive, highly respected for his work in vaccine development and a major pharma, was co-director along with Gus Perna, General Gus Perna of the Army. They led this effort, and then they pulled in talent from all those agencies, including DARPA, to kind of run a new organization where the people seconded up from the agencies owed their loyalty towards that new organization, but they kept their ties back to their own existing organizations where they could bring in authority and capability, know-how, and talent to apply to the particular task they were tackling. It's a very different way of organizing interagency coordination, and I think it stands out as kind of a new model that we need to think about.
One of the things that struck me in the book is that you talk about unhappiness with industrial policy and attempts to disguise social policy as industrial policy. Um, you talk about needing to put the industrial back into industrial policy. What are you trying to get at with that?
Well, this is where manufacturing and industrial innovation policy intersect, right? Um, you know, innovation is going to require a lot of hard tech, inevitably, and we see this all around us. And we aren't going to be capable of doing industrial innovation policy for the economic security and national security goals we've got unless we significantly strengthen the manufacturing production system. In the end, you got to make a lot of these technologies to get the innovations into place. So we need to conceive of the industrial production system as very much part of the industrial innovation system. And I think that phrase is exactly apt, the one I use, which is you've got to put industrial into the industrial policy. And we've been neglecting, as we talked about earlier, our manufacturing side for too long. We really need a new systematic approach to a series of steps in manufacturing.
And it struck me in all of the examples where you sort of lament the lack of this use of tools, this agreement on the need for industrial policy on the civilian side. These are all things that we sort of take for granted on the defense side, right? The ability to invest in R&D through the services, through the DARPAs of the world, the ability to scale up and prototype and even invest in manufacturing, the ability to certify technologies through our rigorous testing system, and then even the ability to both buy and then distribute and sustain a technology as the first user. We kind of take all of that for granted on the defense side, and it doesn't really exist on the civilian side. You call that model in the book, if I got this right, sort of an extended pipeline of innovation. And I just want to poke at that for a second. I think DoD is an example of an extended pipeline, pulling innovation from R&D into use. But DoD's procurement system is by far from perfect. So what are the negative side effects then of using these extended pipelines?
Well, I mean, the extended pipeline is, if we look at Vannevar Bush's pipeline theory, right? The guy who was Roosevelt's science advisor who kind of designed the post-war R&D system. Vannevar Bush's view was that there's an innovation pipeline and the federal government's role is to dump research into one end of the pipeline, hope that mysterious things occur in the pipeline itself and products will emerge. The extended pipeline is a more conscious and more organized approach. It requires not only the input on the research side, but supportive inputs all along that pipeline, the extended pipeline, where you've got, the connections being made between the innovation actors all along that system to enable it to work efficiently. I think, I think that's an important model. And, we've got, as we've discussed earlier, we've got this economic security challenge that's in many ways deeply related to the national security challenge. And, the defense world has thought about getting specific defense products. How many jet fighters are we getting? How many aircraft carriers? How many submarines? It's very platform oriented, right? But it has not paid, I would argue, enough attention to the underlying economic security side, where we've got to start looking in a larger sense at the overall technology base and the overall manufacturing base of the economy because they are direct contributors. Um, let's talk for a second about the CHIPS Act, which was funded in 2022. Semiconductors are an absolutely core enabling technology um, for a host of most complex products are now have semiconductors at their core. Um, there's semiconductors increasingly in everything. Um, there may be as many semiconductors as there are trees at this point. And we're starting to work on as many semiconductors as there are leaves on trees in the world. So it's the need for complex civilian goods is going to be paralleled, I think, on the national security side. So the Defense Department has been able in recent years to pay less attention to advanced semiconductors, because it was using legacy semiconductors, older, less powerful, less energy efficient semiconductors in the goods and equipment that it was creating. But we're increasingly seeing that things like artificial intelligence, quantum computing, autonomy, including autonomous drones, for example, uh, critical data centers for command and control. All of these are going to require the most advanced chips. So the Defense Department is going to be back in the business of supporting advanced chips. It was there once, right? All through the Cold War, the Defense Department played an absolutely crucial role in the evolution of semiconductor technologies at many stages. We dropped that to some extent at the end of the Cold War. DARPA began working on its electronics research initiative, about 5-6 years back. That, in many ways, is a prelude to the understanding that led to the creation of the CHIPS Act. But the realization that advanced semiconductors are going to be a critical defense need, that enabled that legislation to move. And it provided, as people in this call know, direct production support. So we had $39 billion to give us the next generation of semiconductor fabs in the United States. We hadn't been building semiconductor fabs in the United States for 15 years. We were making them abroad, and new companies were advancing to fill that gap, but they weren't being produced in the United States. The point there is that why does the federal government have to play a role? It turns out that government subsidies are responsible probably for 70% of the cost in offsetting the cost of semiconductor production. That's the differential between 70% is the differential between U.S. non-subsidized and a subsidized plant in, say, Taiwan or Korea, or for that matter, in China. That's the volume and scale that governments have been prepared to invest in semiconductor fabs to get these critical technologies, in their countries in the production stage. So we invested $39 billion for new fabs. Look, but it's only going to get us the next generation. What's going to happen after that, right? We also had investment tax credits and loan guarantees programs in addition to that direct grant program. But direct production support is not cheap, and it's not going to be easy in any area which doesn't have a pretty direct national security connection like semiconductors do, or at least an understandable connection. We also had $12 billion in R&D investment. The CHIPS Act, however, is only authorized for 5 years. And while its funding can remain available for a longer time frame, we've now spent down the direct fab construction funding. The R&D money is just being organized. The investment process in that is just starting. But I question whether or not the CHIPS Act is going to get renewed in the current political environment. It may well not. So what's going to happen next? And here's where I think DoD can play a significant role. And this is an example, I think, of how DoD needs to start thinking in a broader way about these economic security issues. It's going to have advanced chips. The CHIPS Act is going to run out. We're going to have to think about financing mechanisms to make sure that we have the next generation of fabs being located to some extent in the United States. We're going to need to think about DoD is a low volume user of increasingly customized chips. Uh, that's not the model for the volume you want out of your fab. So DoD has very little market leverage, but it needs these increasingly customized, specially designed chips. Frankly, that's the direction industry is going. Look at the GPU chips being used in AI. It's a signal of increasingly specialized chip designs. Chip design is extremely expensive. I asked a friend of mine from Microsoft, what it took for Microsoft to do a big new design. Said, 400 engineers, $1 billion. That's not the kind of cost that DoD can easily absorb. Uh, so it's going to have. There is a possibility, however, with AI of really, what I'll call modularizing the chip design process, creating a series of design modules that can potentially very significantly reduce the amount of engineering input that has to go into each new chip design, maybe by an order of 10. Having lower cost design, DoD would be a huge beneficiary, but also industrial users would be a huge beneficiary. A major chip design project, perhaps led by DARPA, would be highly advantageous to DoD, given its customized chip needs, but also to civilian industry. A collaborative effort would be possible there. Another key issue, and this is the last one I'll mention, although there's others, another key issue is going to be longer term R&D. The CHIPS Act will get us through a series of interim technologies. We're going to have it'll support things like packaging and integration possibilities. But longer term, we're going to have to move away from CMOS, the current fundamentals of chips. And we're just running out of the scaling down that we've been able to do. We're at 3 nanometers, we're headed towards 2. Maybe we'll get conceivably to 1.5 nanometer chips, but that's as far as it's going to go. We're going to have to do something different if we want to keep chip advances on track, which we're going to need for things like quantum and we're going to need for AI and so forth. So how do we do that? Post CMOS R&D is going to be critical, and we're going to have to do that at scale. And that's a role DoD could start thinking about. It's historically performed critical R&D roles on the chip side, starting in the 50s. It could pick that role back up and assure itself of the kind of advanced chips that its systems are going to increasingly need. So those are just a few thoughts on this whole point of, how do we do the extended pipeline and what's DoD's role going to be?
So, Bill, with the time remaining, I wanted to ask about a couple other pressing issues facing the new administration and new Congress. One is this desire to engage all of the private sector money that's being invested now in R&D and innovation, including in areas of interest to DoD. The book does a good job of laying out the trends in increased private sector investment in some of these areas and their increasing role in some of the areas that DoD cares about. What would you say is the modern version of industrial innovation policy that embraces the presence of VCs and private equity and other forms of private capital that are going to play a big role in defense innovation?
Well, let's talk about the manufacturing side of that question, where we're not getting good venture capital entry, for example, into manufacturing for the reasons we talked about earlier. How are we going to scale up the production system? And look, developers in Europe have been teaching us some important lessons about the fragile nature of the defense supply chain. We have some real gaps that have been exposed in our ability to, supply missiles at volumes, to supply even artillery shells at volume. It looks like the U.S. would be in pretty good shape to fight a war that lasted 6 months. Anything longer than that, we're going to start running into these big industrial base scale-up problems. And so scaling up manufacturing is, is this direct defense problem now, aside from being an overall problem for the U.S. economy. How are we going to deal with that scale-up challenge? As you pointed out, Arun, in your question, there's a huge volume of capital investment potentially available in the United States, it's not going into manufacturing. It's not going into the production system. How do we create the incentives that would actually drive investment in areas that are important for our economic and as well as directly related to national security? How are we going to do that? We're not going to do state capitalism, right? We're not going to do China's state capital system. It's not us. It's not our system. But we've got an ocean of capital, and we don't have the drivers that are going to move it onto some of the problems we need to solve. So we've got to start talking to that capital community and find out what the incentives are that might drive them to assume higher risk manufacturing related capital investments. And I know the answer is out there. Now, there's also some other mechanisms that we've got potentially available, including at DoD. The Office of Strategic Capital, which has just been set up at DoD, and it's now got some funding to be able to offer kind of loan guarantee funding. I think the current authorized number is 400 million for that. It'll enable a bunch of pilot projects. But that's a tool that the Defense Department in areas of critical technologies that it cares about and supply base issues that it cares about, where it could invest in the kind of advanced manufacturing approaches that we need to invest in. The defense procurement system, right? Everybody has heard of computer-driven machine tools. They're pervasive and they are key. How did they come about? The Defense Department was the huge enabler. It had to have a much higher level of precision for the parts that were going into its missiles and rockets. And CNC equipment was the answer. It had been developed by a private sector inventor as well as inventors at MIT. DoD saw what the possibilities were for this new kind of precision, how important it was going to be to DoD. It decided to use its procurement system to get there. So it created a requirement that defense contractors building certain kinds of equipment had to use CNC, computer-driven machining systems. That equipment was expensive at the outset, of course. So DoD bought a host of it and then leased them at very low prices, which could be recaptured in the contracts, leased them at very low prices back to defense contractors. Everybody switched, right? The defense industrial base was significant enough and remains actually a significant part of U.S. overall industrial production, somewhere in the 8% range, was pervasive enough that it led a whole technology revolution in production into a whole new level of equipment. We can use the procurement system for requirements and proportionate support, including through tools like the Defense Production Act, to get the advanced manufacturing technologies that we need into U.S. industry. It's a particular defense need, but it's a broader need as well, and it can scale from the defense side, as we showed with CNC equipment. So there's other tools out there too. I mean, there's been an effort to get the Export Finance Bank, EXIM, to provide financing for manufacturing scale-up. It's got an $80 billion line of credit, approximately. That's a substantial resource pool. It's got a charter that includes broader manufacturing lending. And it's initiated a pilot project now, providing scale-up for an aircraft manufacturer, doing new technology approaches to get its production system scaled up. That's an existing bank. It knows how to do lending. It's profitable. It doesn't cost the federal government money. We ought to be able to do this lending task in a way that doesn't outrage the taxpayers, that more than breaks even. It's just another kind of capital financing problem, and it's a matter of creating the right incentives and mechanisms.
So, Bill, last question here. New Congress is coming in. You spent a lot of time in Congress working on armed services issues, civilian innovation issues, manufacturing issues. If you had one wish to see Congress do something in this space this session, what would it be?
I think this scale up problem is a huge one, and we haven't really tackled it. As I said previously, China's spending about $500 billion a year on industrial scale up to scale up its manufacturing. We're not doing that. And we don't really have private sector mechanisms that do this very well. So, particularly for new production technologies. So, we're going to need to figure this one out. And I think Congress working on a, a production scale up financing mechanism, creating the right incentives is going to be key. The approaches are going to have to get figured out on this financing task, but I think it really needs to get tackled if we're going to be in the game. So that would be at the top of my list on the congressional side.
That's great. The book is Pioneering Progress, American Science, Technology, and Innovation Policy. The author is Bill Bonvillian from the Massachusetts Institute of Technology. Bill, can you tell us how to get the book?
It's actually available free. It was published open access by MIT Press. And you can, of course, buy a copy, which I'd be delighted to have you do, and order it through MIT Press or the other sources. But you can also go on the MIT Press site for the book. Just put in, Bonvillian Pioneering Progress, MIT Press. Go on the book site from MIT Press, and then look for a box that's labeled Open Access. Click on it, and you can call up online the book. You can also download chapters.
And we'll drop a link to that in the text box here on the video. Thanks again, Bill, for joining us today.
Thanks, Arun. Thanks for your great questions. Enjoyed the discussion.
Thanks, everyone, for joining us for another episode of Emerging Tech Horizons. Appreciate your support for the podcast. I want to remind everyone to go to ETI's webpage and NDIA's webpage to see all of the webinars, the events, our big conference coming up in August, the Emerging Technologies Conference at the DC Convention Center, and everything else that our institute is doing. If you like the podcast and want to see more or different guests and topics, please email us at eti@ndia.org. And don't forget to like and subscribe on YouTube and other platforms. Thanks for joining us today.